want to continue talking about geometry, and now I want to make sure that you know how to use a protractor correctly. And so go find a protractor. I'll wait. All right, are you back? Okay, you got your protractor? So take a look at your protractor and see, is it a protractor that looks like this, or is it a protractor and it's going to look like this, but it's got an extra line on it. So if you look at the one that's on the screen there, you see it's one of these kinds of protractors that has this extra line, and then in the middle it's got a dot right there. So the first mistake that some of my students do whenever they use a protractor like this is that, let's say that they are trying to measure this angle, they will take this protractor and they will slide the bottom of the protractor onto this line, and then they don't get the right answer. Now, if you've got a protractor like this up here that doesn't have this extra line, then you really are supposed to do that. So this thing will have a dot right there, and you'll take that protractor and you will place it on there so that this dot is right there, and then you have no problems. But just remember that if you're using a protractor like this, that you need to take this line and put it on top of that line, and then again put the dot there, and then you're going to get the right angle when you do that. Another thing that is tricky about protractors is looking at the numbers. So you'll notice that these protractors have two sets of numbers. And so it goes from 180 degrees to 0 over here, but then it has another set of numbers that goes from 0 degrees to 180. So why is it that you have two sets of numbers? Well, this is if you're measuring angles that are going in that direction, and then this is if you're measuring angles that are going in this direction. So in the problem there, you've got this angle is A, and then B is over here, and then O is the origin. And so we're trying to figure out what is this angle in here. So if we had used the outer set of numbers, you will notice that it turns out to be 120 degrees. So if we use this, the outer set of numbers here, then this would be 120 degrees. If we use the inner set of numbers, notice that it's going to be 60 degrees. So which number are we going to use? So remember that if you have a right angle, that's 90 degrees. So this is a 90-degree angle right here. And notice that this is bigger than 90. So 120 is bigger than 90. So this is not the right number to use. So we're going to use the 60. So this would be a 60-degree angle. Now, if on the other hand, you were measuring an angle that was like this, then you want to use the other set of numbers. So in that case, you would want to use the outer set of numbers if you're measuring this angle on it. So be careful about which set of numbers that you're using. In general, always use the smaller set of numbers. So if you got a choice between two numbers, then pick the smaller of the two numbers, and then that way you'll get the right angle when you do that. Another thing that I want to mention is the units for angles. So let me clear this off. And you should be very familiar with degrees, so that if you go around in a complete circle, then that's going to be equal to 360 degrees. So that's what that protractor in the previous slide was measuring. So one circle, one rotation, or one revolution is equal to 360 degrees. But it turns out that there is another set of numbers that we tend to use in physics in our formulas for rotational speed and rotational acceleration and so forth, and that's going to be called the radian. So one rotation is going to be 2 pi radians, and then pi is going to be 3.14. So the radian is really the correct unit to use in physics formulas. So where does the word radian come from? So that if you have a circle and that circle has a radius r, and then let's say that you got a piece of string and you measure that length, and then you take that length and then you wrap it around the outside. So this distance here is still r. And then you connect these 2 points, then this angle here is going to be 1 radian. So that's the angle. 1 radian is if this length is exactly the same as that length right there. And then if you went completely around, it turns out to be 2 pi radians. So here's an example of how to use this formula here. So convert 45 degrees into radians. So do you remember, to convert something, you always have 2 sets of parentheses. And then in the first set of parentheses, you write down what do you start with. So you're starting with 45 degrees. Okay, now the second set of parentheses is going to be your conversion factor. So we're going to write it like a fraction. We're trying to get rid of what? Degree. So that we got a degree on the top and a degree on the bottom. So they're going to cancel. And we're trying to go to radians. So we're going to put that on the top. Okay, now 2 pi is next to the word radian. And then next to the word degree is 360. So therefore, we're on our calculator, we're going to take 45 times 2 equals, and then times 3.14 equals, and then divide by 360 equals. Now, did you see that you can do that all at once on your calculator, but you tend to make mistakes when you do that. So I recommend that you take the 45 times 2 and get an answer. Take that answer times 3.14 and get an answer. Take that answer and then divide by 360. And then that's what it turns out to be. And notice that the degree canceled, and the only unit that you're left with is going to be the radian. Okay, let's take a break, and when we come back, we are going to talk about what is the difference between an inversely and directly proportional formula.